our image, elephant image as an input we are giving to our trained machine. The trained machine will go for dividing the total images into various sub images or sub pixels in terms of vectors, right? And it has to analyze, it has to represent with some label, right? 8 by 8 or 256 by 256, like that pixels we are dividing. For that, finally we go for representing. The second way of machine learning step is representation of the particular image. Third one is called modeling. Modeling means we have to give for after segmentation part is over, we have to go for labeling. So with some modeling, right? This one is give some class values, right? The class 1, class 2, class 3, or matrix 1, matrix 2, matrix 3. Finally, we go for dividing the total images into various sub-images. After representation, modeling of the system is done. And estimation. What is estimation? After giving input to our data, we need to go for extraction of the features. So how many of you know that how many features available with respect to images? Whatever may be the data, you can take images, or we can take CT scan images, MRI scan images, or X-ray images, or remote sensing data, whatever may be the things we are giving as an input. What we need to do is we need to feature extraction. We need to extract the features. Then tell some of you how many features are there. You might have studied in that rest of the 4 days about the feature vectors. What we can take as a feature from the image? Can anyone tell? What are the types of features we have? We want to carry out any type of research, we need to take the feature set as very important, right? What type of features we have? So we have so many types of features, right? Like texture features, if you want, or any shape or size or any geometrical features, right? You can take, right? The texture features, whatever may be the features we are taking. After taking the features, we need to store all the features in some data set, right? Or in some database, or we can say in some support vectors, right? Or we can say it is a or some data set is required for storing all these values as pixels or some pixels values, right? Regarding
Excuse me,
that
sir.
texture, what?
Excuse me,
Tell me
sir.
one.
The screen is not visible. Only the empty screen is there.
Screen is not visible.
Yes, sir. Yes, sir.
Wait.
Thank you, sir.
Is visible?
The screen is visible, but the content is not displaying.
Content is not visible. Now it's visible, ma?
So the several windows can be displayed as parallelly.
Oh, now it is visible.
Yes, sir. Yes, sir.
Okay.
Click the PPT.
Visible?
Sir, only the 5 contents can be available. 5 icons.
Now it's
You can
visible.
display icon is visible.
Like go for the. Is it visible now? Can we go? If I go for that slide, so means it's not visible, I think.
Okay, do it, sir.
Now it is visible. Can I go like that?
Okay, sir.
So now we are discussing almost about that steps in machine learning. So many steps are there for doing our research. What are the basic steps involved in machine learning, like data collection, we know, representation, modeling. While go for estimation, it plays a vital role. As a researcher, after collecting the data, we need to go for estimating the values. What are the various possible estimation methods available? Having collected that pixel value and store it in your database, what we are going to do with the data? I have one image, say for example, 500 cross 500 pixel values I have. That image I have given as an input. Having given that input, I have taken some texture features from that. And what are the texture available? So many texture features are there. Tell me some of the texture features like energy, like entropy, contrast, right, brightness, autocorrelation, skewness, right? These are all some of the basic texture features available. And of course, go for geometrical features also. Say, for example, if you are going to like to carry out any research with respect to tumor identification, you are giving input as a CT scan images or MRI scan images. Having given that the tumor value, we can easily find how much data required, in terms of geometrical analysis, shape and size of the particular region of interest. We are going for region of interest. We are going for segmentation. In that segmentation, we are easily identifying that pixel rate of the values, right? Pixel rate means what? The size of that region of interest is very important because we are after giving that input, after pre-processing is done, we are segmenting the image into various regions. What region we are interested at a particular time, particular area the tumor finds or tumor is found. In that area only we are interested. Further, what we need to do, we have to take that data, feature vectors from the data. How many data we are going to take? We are calculating all the estimation values like energy, entropy, right, contrast, brightness, skewness, right? All these values we can easily take it from that particular important area of region of interest. After applying that, we are to validate the system. Validate the system means what? We are training the system. The system never knows. We are writing the program. We have to take that features, dividing into this kind of 8 by 8 pixels or 2 display. After all these things over, we are labeling into various classes like class 1, class 2, class 3, class 4. After collecting all the pixel values, we are calculating that feature values, texture features values. We have to validate the system that whether tumor present or not.
Excuse me,
What?
sir.
Tell me.
Sir, PPT is not visible, sir.
Why this class? I am sharing only.
Initial onwards, only the 4 icons can be there. You can click
Okay.
the PPT and then the slideshow will be there.
Okay, ma. Wait, ma.
Okay.
Wait, ma. It's now visible, ma. Madam.
Sir, only the 4 icons can be visible. But you have to click that, then only PPT can be visible, sir.
It's now visible or not?
No, sir.
No, no.
Hmm.
விசிபிள் ஆகலையா சார்? இப்ப விசிபிள் ஆகுதா? இப்ப விசிபிள் ஆகுதா? பாருங்க.
Sir, now you can opening any prompt, D prompt or E prompt. Then after that, so many folders can be there, means that will be displayed. Like that only display, sir. So you have to clicking your machine learning presentation. This PPT can be selected one, sir. If you have to
வெயிட் பண்ணுங்க
click
சார்.
that, then only it can be viewed.
ஓகே ஓகே ஓகே. Is it now visible, ma?
Sir, same thing, sir, happens.
Same thing happens, sir.
Only the 4 and 5 folders can be displayed. 5 files. You have to select in the which one machine learning presentation PPT.
Not visible, ah?
Same thing, sir.
Same problem.
Yes, sir,
Uh,
not visible.
Now it's visible, ma?
yes, sir.
Ah,
Now
yes, now
visible.
visible, sir.
Okay, sir. Okay. So what we have discussed so far, that validation part is very important. Tell me that idea of validating, why we are training our system. We are training our system only for identification, right? So for example, for 600 images I have taken as an input, I am training the system and store it in the database. Some new system enters, right? Say for example, I have listed so many animals, 500 animals I have trained. Some new animal I am given as a new data set, but system never knows, right, what type of image it is, right? It has to carry out all type of segmentation, region of interest, classification. It that particular new data, which is coincidence with the already trained data, will be displayed. And after displayed, we have to validate the system. While validating the system, we have to let us know that what type of input we are giving, what type of output we have taken, and we have to finalize that. So, for example, if it is a medical image related operations, whether tumor is present or not, what type of tumor, whether it is benign or malignant type of features, all this data we are going for applying. So, after validating part is over, we are applying learned method or model to new data set. That is important. So, this one is that general structure of a learning system. The learning system consists of a data, that what we have discussed in the previous slide is given as images here. Learning process is here. After learning process is over, solving the problem, we are going for performance evaluation. During the time of performance evaluation, the teacher is going to give our own data and we are checking. If it is result is good now, we are going to taking that performance. If the result is not up to the level now, we have to once again give the feedback to the learning process once again. Right? This is particular thing is carrying keep on continuing for every time. Finally, we are going to get the best results. Right? That general structure of learning system is visible here. So normally we go for considering the advantages of machine learning. So many advantages are there. We go for giving vision problems. So for example, while seeing the CT scan itself, the radiologist can understand, give the solution observation on the write-up. Why we need to go for the statistical analysis like that? Where if you are having any type of trouble, the doctor advised to you to take some CT scans or MRI scan. Even the radiologist present in that scan center can observe the things and he can write the what he observed, right? And what is that computerized diagnostic system is required? What CAD is required? Computerized aided diagnosis is required. Sometimes the pixel growth is very that. Tumor growth is very less level, right? Accuracy rate on the micro level. That type of micro level observations or tumor identification can never be felt with that scan report, right? What we need to do is we need to go for a statistical analysis report once again. What type of statistical analysis report? For that only we are training the system. What type of images segmentation and during that is any support vector machine or equilibrium distance or nearest neighborhood classifier, we are classifying the system and we are predicting that particular tumor is cancerous or non-cancerous. I am my area is medical images, that's why I have taken medical images as an input, right? So intelligence of the common sense, right? By seeing or visually visioning the problem cannot able to understand. We have to intelligently tell that the particular system is quite good enough. That what the system or machine learning is doing, that we have to be a that trustworthy things are there. And then constraints over time over complete autonomy. Reducing the constraint is more important, right? Yeah, up to that machine learning, we are reducing the number of constraints present with respect to constraint also. Conditions, if it keep on going, computational complexity will be raised, right? That's why. And second, the drawback related with the machine learning, already told, it is only an application specific algorithm. Application specific means what? Say for example, I want to detect the fire happening in the forest means it is application specific. I want to carry out my machine learning for medical imaging, it is application specific. Whatever the things we are doing, it is application oriented. So real world problems have too many variables, right? Too many sensors might be. If you are going to carry out any IoT related machine learning, it is nowadays a very popular IoT. We are going to carry out any type of IoT. Some common task is, say for example, IoT traffic management or drowsiness of the drivers while carrying or driving the. All these things are IoT. We need some sensors. If you are carrying out, keeping on the sensor, finding the traffic density or traffic management system or traffic light signaling, all these we require sensor. What is the role of the sensor now? Sensor may be highly, it is a hardware device only. Noise will come from the device. Almost accuracy level is somewhat reduced. So many vendors are there with respect to sensor. Say for example, IR sensor may be developed by one particular company. We are going to use, our system will support for that one. The complexity is there. Too many variables, too many sensors, quite noisy. All this may be a identification of some real world problems with respect to drawback of machine learning. Of course, computational complexity. What is the term computational complexity? Anyone tell? Having completed your research, you might have come through the two things. One is called computational complexity, another is called the time complexity. Space complexity, computational complexity, time complexity. Computational complexity means what? Our system won't support for our speed of operations. If you are really going to work with machine learning or deep learning in your research, of course, the computational complexity will be raised. We need to reduce. For high-end systems are required. How much time the system is taking for producing the result? That is very important. How much errors are there? That is where we are going to error corrections, error rate, and accuracy. For this, played a very important role. So computational complexity, as we are training the system for more than the thousands of images or thousands of data set, the complexity will be increased. Our aim is to little bit reduce that computational complexity as well. Now we come to the types of machine learning. As you know, wherever you are studying like image processing, that two things are you may be familiar. One is called unsupervised learning, another is called supervised learning, right? And in that, in machine learning, we have one more intermediately we are having called a semi supervised or reinforcement type of learning is there. So what is unsupervised learning? Anyone tell, please? Can anyone tell unsupervised learning? Because it is very basic in any type of research. Can anyone tell? If it is wrong only, no problem. We are going here for discussion only. Unsupervised. Have any idea about this one? Without having the prior knowledge of the particular pattern or input, we are going for taking it account. No outputs are used here, right? Having that input pattern, we are going to reflect some statistical structures of that input patterns. Having collected the statistical structures, we are going to understand only. Without having the prior knowledge of the input data, we are going for working. That type of learning is what is called unsupervised type of learning. Here we don't have any, no outputs are used. Already we have one input and got the output. That output can be taken as an input feedback. No outputs are used here, unlike reinforcement learning or supervised learning. Here only unlabeled data. We don't have the labeled data. As we are having the output, we are taking as an input. When we are trained the network now, we can have the labeled data, but unlabeled data is here. There is no feedback provided in that environment from the environment, right? So unsupervised learning is something called as the raw data we are using. No outputs are used here, like unlike supervised or reinforcement learning. No, or only unlabeled data is here. No output is here. No feedback is here, right, from the environment. So drawback and advantages we need to learn from unsupervised learning before going to start. Most of the science laws like law of energy, law of conservation of energy, whatever maybe the law of motion, they are following unsupervised learning. We don't have that feedback mechanisms there. They are simply inventing. The drawback is complex problem is many situations, right? Feature itself is a complex problem. We don't have the prior knowledge about the input, we are training the system means what? Some complex problems will arise. System may fail at more number of times, right? This will be the common drawback of the unsupervised learning. Now coming to that semi-supervised or reinforcement type of learning. What is that? Semi-supervised, it is intermediate between supervised learning as well as unsupervised learning, right? What is the goal of having this reinforcement? The goal of the reducing the amount of supervision required. If you go for a supervised method, number of supervision required is much higher. We need to reduce that one. If you want to reduce that one, what we need to do is that the complexity of that supervised learning should be reduced first, and unsupervised also have some problem with clustering, improving the result expectations provided in unsupervised clustering. That expectations of the user is also going to be reduced. That for that only we are having that intermediary rules like in between supervised, reducing that number of amount of supervision. Results of unsupervised clustering is also having that problem. For that only we are developing this one. And moreover, in semi-supervised learning is an area of increasing importance in machine learning. Importance in machine learning means what? We are having that area of how we are increasing that importance means what? Automatic method of collecting data is more important than developed method to use. So as we have the unlabeled data, automatic method of collecting the data is more important. That's why we are simply coming to semi-supervised learning. Now coming to the supervised learning, very, very important. Many, if you go for medical image processing or deep learning, this is very important because these two are you are going to concentrate on your research. Having collected that research, the supervised learning plays a vital role for image processing nowadays. We'll go for supervised learning. Two types of supervised learnings are there. One is called analogical learning, another is called as decision tree. These two are very important. What is analogical learning? Now we are going to see analogical learning. Supervised classification can be classified into two things. One is called analogical learning and decision tree. Analogical learning means what? The instances of the problem. Instances of a problem means what? Learner has to form a concept that supposed most of the positive and no negative instances. What is that more positive and the learning instances? Have anyone know? Many number of instances. What the purpose of doing this one? What is the purpose of doing our research? Our aim is to reduce the negative instances and we have to improve the positive instances. How much positive instances we have? Then we have to go for using that analogical learning. How much positive instances we are going to produce in our research results. Right? In the form of some concept of inductive learning, we are saying. Right? Say, for example, this will be the complex analogical learning we are taking into account. What will be the problem instance we have? The input, most of the things we are training the system. While training the system, the problem will occur with the verbal. Say, for example, all type of singular plural, how it comes. Say, for example, for actor is a singular, actress is a plural form of actor. Right? Right? We are having toy, toys, books. This we have trained the system. Some in typical cases are there like fungus, fungi. This will be a singular form. All we are adding yes with that singular. The system will have trained like that. Analogical learning will identify this, sort out this problem also. How this sort out? Singular form of fungi is fungus. We know that system will understand fungus is a plural, fungi is a singular. But what actually happened in your verbal? Fungus is a singular and fungi is a plural. For that also, we need certain type of operations we require. So main step of involved in analogical learning are now very clear that formalizing that identifying analogy. Identifying analogy means what? Through some experiential problem instances and new problem we are going for demonstrating. Already we have some experienced problem instances and a new problem it comes in between the similarity we have to identify. For that we need to go for mapping functions. How we can go for mapping function? Right, already trained network, we go for the input network, go for mapping. What type of mapping we are doing and selecting that the mapping is determined. Having identified the mapping, we are going for applying the mapping functions as well. New domain with already existing domain, we have to find the target domain. So analogical learning is more important. We can go for taking or considering any type of researches, any type of research, you can do it with in your own method or in your own method, we can easily carry out any type of analogical report, right? And regarding that cardinalities and function that we can see. So finally, what is essential means gate operations. We are going for gate means what? Validating the system. Validating the system means newly constructed solution is to be validated with some theorems or proof. That is very important. We are going for presenting that if it is a tumor, if it is a cancerous or non-cancerous tumor, we have to validate the system quite confidently. No healthy person should not be predicted as a tumorous person or cancerous person. Our system failed in that angle. So validating the system is more important than any type of system. While validating the system, we need to take into account more theorems and laws and simulation results. And learning, if the validation is found to work well, the new knowledge is now encoded and can be saved for future usage. Right? So I already told about that operations regarding the first supervised method called as analogical learning. In that analogical learning, this will be the training methods involved in your analogical learning. Say, for example, I have already trained fungus, right? It is a singular form. The system has been trained with some trained data. The output for that fungus is fungi. Already I stored, right? That system has been developed like that. New instance arise. The new instance by the name called bacillus is coming, right? The new instance has to be given as a given for our trained network or machine. The machine is going to understand what the bacillus, what would be the plural form for bacillus. So first it is detecting that fungus fungi, we have the similarity FUNG will be the similarity value, and difference is what? US, right? FUNG is equal both in singular form as well as in the plural form. What is different? US has been changed into I. So the difference value is US. So that US we are going to incorporate that whenever US come for any type of values or singular form, we have to give I as a value. That we are going to give as a feedback once again, and that feedback can be given for bacillus as well. So bacillus, your US will be converted into I, then we are giving the value called bacilli. So now the system has been trained in that value. Similarity value we have to find, deducting the similarity. Whenever what is that not similarity value is US, whenever the US come, we have to map with that mapping function called I value. That I value can be given as a input value base target value. That will be given as a value. Now you understand, ma? Whatever may be the example we have trained for the system will already go for the new set of data. Will go for taking to consider for already trained network. In that already trained network, what is that similarity index it has to find? What difference value will be assigned now? And that will be bacillus as a new data instance, and bacilli will be the output for this. This will is called now the second part of the learning method. First part we academical. Second method is what is called from decision tree. Using the decision tree, what we are going to take. Right? Already you know tree will be formed like a nodes. So many nodes are there. Right? Say for example, if it is a Boolean function, we have only two values, either true or false. Beside the range from 0 or 1. If it is a binary value, we have only two values like zeros and 1. If it is a non-binary value, we have so many instances. Then we have to equip our system, train the data based on that various nodes, various instances, like possible values for this attribute. Then we have to train in that angle. How we can train? Say for example, our aim is to produce so many type of positive instances, right? Those instances, as we can say, is a true value. Whatever may be the new data arising, we have to, at maximum, we have to produce the positive instances or the true value. If we go for other hand is called the negative instances, right? We may consider how the positive instances and negative instances plays a vital role. Say for example, if you are going to carry out any type of research, if you want to calculate the accuracy level of that particular input data, we need to calculate the sensitivity and specificity. If we now need to calculate the sensitivity and specificity of that input, we need to have so many cases like true positive, true negative, false positive, false negative. Based on this value, you need to calculate the sensitivity and specificity. Finally, we go for calculating the accuracy level and true error rate. Whatever may be the inputs we are giving, I have to soundly, proudly say that my research is fulfilled with this kind of accuracy. Already we have 94% of accuracy for that value. I have to clarify that my accuracy level is 95% for that same data. If I produce 95 means what? I have achieved something. Some new things I have found. New research I have created. Like that I have to produce the paper or something like that. Right? And negative instance also, of course we have. Say for example, I have taken an example of the instances. 9 instances I have given for that fly of a bird. Bird has to fly. How many instances I have taken as input? 9 instances. How many wings? Of course, you know, bats have 2 wings, right? And having that wings, we are going to mix it with so many instances. The first instance, say for example, the bat is having 2 wings. The bat is having 2 wings and broken wings, if any. I have added one more parameter, that broken wings, if any. In first instance, number of wings is 2, broken wings is 0. Now I am concluding that living status of that bird is alive. It is alive only, not dead. And after that, I have to calculate one more. I have to add one more parameter, that weight of that bird. Weight of the bird means what? Wing area or weight of the bird. If it is greater than that of the bird, weight is more than that of 2.5. Then I am telling that the bird will fly or not. Having alive or not, we will having alive or not, and we have to check the condition that the bird weight is 2.5 or not. right? With this conclusion, adding one more parameter. I know it is alive. Once again, no, even though it is alive, it has not, it's supposed to fly or not. That we have to understand. How we can identify those, it is flying or not flying. One more parameter adding by calculating the wing area of the wing divided by weight of the bird. And if it is greater than that of 2.5, only the bird will fly. The first instance, all is going on well. Second instances I am taking. Number of wings is 2, of course, right? Broken wings, if any, one wing is broken, right? One wing is broken, even though the living status of the bird is alive, and I have to check if it is 2.5, less than that of 2.5, if it is supposed to be there. Broken wing, only one, of course, that the weight of the wing is more than that of 2.5 in second instance, but the wing is available, wing is only one. The bird can't fly. So this one is also taken as a input condition. I am concluding that the bird fly is false, second instance. Third one I am taking. Number of wings is 2. Broken wings, 2 wings are broken. And even though the bird is alive, even though the weight of the bird is more than that of 2.5, 2.6, bird that tried, the bird cannot fly. I am giving that false here, right? And fourth instance also you can take, 2 wings are there. Number of wings is 2. Broken wings 0. And what about that? It is alive. But even though the bird weight is more than that of 3.0, right? As we have no wings are damaged, so it is true, right? And fifth instances are a bit dead. 2 wings, number of wings present is 2. Broken wings 0. But living status of the bird is dead. So living status also we have to take as a parameter. You have to check. The wing area is, of course, the bird wing area is 3.2. It is having 3.2. Even though it is having 3.2, it is in the death rate. As the living status is dead, the bird cannot fly. So we have to justify it as a false one. Sixth, of course, no, number of wings 0, number of broken wings 0. Even though it is alive, even though the back weight is 0, false. So many permutation combinations value of parameter we are adding for number of instances. Now, ninth instance you see, number of wings is 2, broken wing is 0, it is alive, and even though it is alive, it is less than that 2.5, it is false, it is not able to fly. In that way, we have to take that every instances you have to add it as a node in a tree. As far as that supervised learning of decision tree is concerned, we have to take all these 9 different nodes as an instances, and we have to add the parameter, and we have to check the condition, and we have to train the system. Finally, we have to give that solution as whether it is able to fly or not able to fly. Right? That example I have taken here. Now, that previous example I have taken similarly, decision tree example, it is seen from the above table that fly equal to true. When the fly equal to true, if number of wings equal to true, okay. And after that we have to check and broken wings equal to 0. It should not, any wing should not be broken. Then broken wings parameter should be 0. And living status of the bird is also to be alive, because the dead bird cannot fly. Living status also alive. And one more parameter we are adding, all these are positive, but wing area by weight of the bird may not be greater than 2.5. Then we have to state that it is fly is not possible. If it is more than that of greater than 2.5 only, we have to conclude that then we can write it is positive, it can fly. If any one of the things is failed, right, we have to check all these decision tree into our account, and finally we have to give the solution for any type of supervised learning. We are supervising. That's why we are name came. What is the supervised? We have the prior knowledge before going for. I have taken 9 instances. Some new bird arise. I am taking the photograph of that image. Right? I am giving the parameter. Only two flies are there. So I have picked one. First one is okay. No broken wings are there. Second parameter is okay. It is alive. That is okay. And weighting parameter is also greater than 2.5. Then your system has to give the solution like the bird can fly. Right? Fly equal to number of wings equal to 2 and broken wing is 0. And one more thing here in the last 2.5. Right? Like that we have to conclude. So the tree like structure, now we are coming. Number of wings, how much wings are there? Either it can be 0, no wings are there, only one wing is present, or two wings are present. If it is 0 or 1, the bird cannot fly. So we can straight away give that the bird cannot fly as a decision. And one more thing we are adding for the child node of broken wings, as it has two wings present. Now we are going to add three things like living status as a parameter. Only one broken wings, again we are having two wings are there. Here also we have to add living status is 0 and no wings are present, only one wings are present, two wings are not present. Like, and living status also we have two parameters, either alive or dead. If it is dead means we have to give the conclusion it is more than the less than the graph, you have to check the less than 2.5, it has to be modified, right? It is wrongly given. Z we are calculating the velocity A by W. If it is more than 2.5 means yes, less than 2.5 means no. In that way, we are adding that node with number of wings with already existing decision tree, and finally we go for giving that conclusion. Now we are familiar, ma, having completed that basic things of machine learning. What are the things we have studied so far? What is machine learning? What is learning? What is machine learning? And after that, what are the parameters present in machine learning? What are the methods we have, like supervised learning, unsupervised learning, or reinforcement learning, or semi-supervised learning? In supervised learning also we have the two methods are there, analogical method as well as the decision tree method. In the decision tree method, we have given with some examples. Now we go for the applications of machine learning, right? Having known about that machine learning, what application we are going to give? Application is enormous with respect to machine learning. We go for the drug discovery, having that given that combinations of chemicals present in the decomposition of the drug, machine learning can easily identify is harmful or harmless. Medical diagnosis plays a vital role for medical diagnosis. Like it's a photo image, MRI image, and CT images are given. We can give some computer-aided diagnosis with pre-processing, segmentation, feature extraction, classification, and finally go for identification of the tumor present or not. So my medical diagnosis, machine learning played a very, very vital role nowadays. Iris recognitions are also there. Iris recognition in those days it was very popular, right? Having clearly the iris, cornea, retina, having cleared that ID, camera captured the eye or authenticating before entering into your project. Handwritten digits are there. So many handwritten digits also. In those days, those earlier researchers, they have given handwritten, given that input value, we are easily finding out how much handwritten digits are there. Radar imaging, of course, you know that satellite images. Having satellite images nowadays, it was very much useful. We are training the system of the input satellite images like weather forecasting. All satellite images are being delivered by the satellites. Having the remote sensing data, we are clearly predicting that yesterday told that today we are having depression is going to be formed. After that, it becomes highly depressive. Storms, cyclones will be formed. All these predictions can be done with the statistical images of the radar images, right? So the image processing is also that machine learning or deep learning played important role for identification of the data. Speech recognition is also there, right? What the word nowadays we are using this speech recognition, having trained the system with our speech, how much decibels it is, what it has been measuring. Fingerprint verification, right? It is also used in machine learning. Signature verification, we are giving the signature, the digital signature has to be verified, right? No one has to take that authenticated signature, right? Having simply put another person's signature in the check, withdrawing that amount is not possible. The machine learning systems will do. Face recognition with so many that fixtures we are having, posters we are having, that faces with so many intensity, so many framework, so many color values, expressions we are taking. All these possible type of expressions we are giving, and particular instances will be given as an input. Target, of course, we find the target recognition. I already told that so many input image we are giving. What is the target? What is the region of interest? the system will easily identify the troops. Then robotics vision. The robotics vision is also easily identified. The robots can easily visualize that any object with some IR infrared sensor. The IR sensor can easily identify that object by way of that ultrasonic. That ultrasonic sensor. What is that? Which bad is not which bad is a blind one. Bat is not able to see the object. How it fly? How it flies, ma? By using that ultrasound sensor, right? Like ultrasound, it is generating the ultrasound waves. Bat is generating ultrasound waves, and whenever any object is found, that reflection of the object can be taken as an input for identification. The bat identifies that here is an object, then it turns left or right. Like that, it using this concept for sensor, the IR sensor will generate an infrared rays. That infrared identifies that any object is present, and like that, robot will make use of that IR sensor to easily identify any object for vision. Taking into account the traffic monitoring system, so many traffic monitoring systems are there. It can easily identified using the CCTV camera. We are giving the input video surveillance input, video inputs as an input to the machine learning. Like frames by frames, we are concluding how much vehicles are there, and that how much vehicles, how much location, how much distance, what is the type of the vehicle. All these can be classified accordingly with that machine learning. And after having analyzed about that all the basic thing about machine learning, now we can take the scope and overview of machine learning by taking into account one applications like medical imaging. Right now we can see. So the research flow diagram is given here. Whatever may be the research we are doing, after having analyzed about the machine learning, we are asking certain question, doing some background researches, we are constructing the hypothesis and test with an experiment and analyze, drawing the conclusion whether this hypothesis is true or false and reporting the result. Once the hypothesis is partially true or false, we once again go for giving the feedback to the constructing hypothesis. Then imaging process, we know very well, so many imaging processes are there, so many methods are there. Of course, we are taking the raw data from the CT scan images. We are giving that filtering. So many type of filters are there. That is keeping that filter for improving the enhancement of the images, right? Improving the quality of the images by filtering, removing the unwanted noise present in the image. A high pass filter or low pass filter or median filter or whatever maybe the filter you are using, that might of noise will be reduced, right? And we are once again go for reconstructing that image. Reconstruction of that image means what? We are going for once again getting back that image, and we are processing that image. We are giving the analysis. That quantitative or qualitative type of output we are reducing, we are preparing. Based on that, we are giving the solution for that input image. Then now coming for converting an image into data. How we can convert the image into data? Right? Either qualitative features are we are taking, or quantitative features are we are taking. Qualitative and quantitative features, statistical analysis report we are taking. The examine levels of findings, feature 1, feature 2, that input scan images I have given here. All this will be taken as a some row and column values, right? Subpixels value for this all the images. Using this, we can take into account all this one. And I have taken one analysis with the CAD, computer-aided diagnosis. Mammography is a best method for identifying the cancerous, right? Mammography image will be utilized here. I have taken here for finding the abnormality in the breast images, right? And the abnormality, how it identifies through, we can easily analyze, right? Using the CAD stages, we have so many stages as well, like medical imaging. Digital mammography, we are going for the first stages, enhancing that images, image enhancement, segmentation of that input image, like region of interest, right? All the 8 water set or region of interest segmentation, whatever it is, doing the segmentation, identifying the area of interest. and finding that the feature extraction. Now we are taking the feature. Already we know many features can be extracted, either geometrical features or texture features or shape or whatever it is, or so many texture features I have given, like shape, size, intensity, correlation, autocorrelation, skewness, energy, entropy, all these can be taken as a texture features, and we are going for classifying that input image with the trained image, and based on that we are giving that report, right? What type of report, whether it is cancerous or non-cancerous. And evaluation of the parameter of CAD can be classified into these four methods. This will be very important. Whenever you are going for analyzing any type of CAD, computer aided diagnostic system, the four things we have to keep in your mind. One is called the true positive, true negative, false positive, and false negative. What is true positive? A case when suspected abnormality is malignant, prediction is true. He is having the problem and diagnosis is true. Then it is called true positive. So what is true negative? There is no detection of abnormality as he is no symptoms of symptoms is found. Then the case is the true negative. What is that false positive? This is very crucial. The person is a healthy person, right? But your system is finding that abnormality is present with the system, right? This should be taken into care, very care about the false positive, right? Crucial parameter in our diagnosis that no abnormality is found in a healthy person, but the presence of abnormality is not true. But we are giving the solution that, but the doctor is telling to the patient, healthy person, that you are affected with the tumor. Then we have to go for analyzing the what type of tumor it is. Wrong input, wrong diagnosis, right? What about the false negative? No detection on malignant lesion is found, proves to be false. No detection, no negative information is given. We are giving the false response, right? No problem. Then, but we have to take into account these two as a very tedious progress of false positive and false negative. We have to take it as a crucial parameter for our accuracy calculation. The second step for calculating any of the features is the two parameter. One is called sensitivity, another is called the specificity. What is the formula for calculating the sensitivity? One is called the true positive divided by true positive plus false negative. This formula you have to calculate, right? And store it in your feature vector. True positive and true negative. True positive by true positive plus false negative. And specificity means what? True negative by true negative plus false positive, right? And high values of specificity will indicate that minimal number of false positive. Then our aim is to increase the specificity. High values of specificity has to be required because it has to reduce the minimal number of false positive cases, right? Wrong diagnosis. Now, what about the high values of sensitivity? It also states that the minimal number of false negative. We have not given any wrong report for wrong persons, right? So the two parameter we need to calculate for our research. One is called the precision parameter, another is called the accuracy parameter. What is the precision? Precision is almost, I already told that precision we have to calculate, right? True positive by true positive plus false positive, and accuracy you need to calculate having calculated the specificity and sensitivity in your research. These values you have to incorporate and show it in your slides. How much specificity you have calculated, how much sensitivity you have got for that input image, how much accuracy rate you have got for that input image. If the accuracy rate is more than that of the already found out value, then you can say that my system will give more accurate than that of the earlier research, right? Accuracy formula is true positive plus true negative divided by true negative plus true positive plus false positive plus false negative. All the four parameters you are given as a denominator, and numerator we can have the true positive and true negative addition of these values. Now, what is the problem with medical images? That you know, you have to calculate. Right? Major challenges is the processing speed. In those days, in 2000, before 2017, I am doing my research. During the time I have in MATLAB, I am working with the raw data. What problem arise in my working? Because at that time we don't have that machine learning or deep learning. Only MATLAB only we are having. The MATLAB tool we are going to use. In that MATLAB image processing, we are taking into account that input images. That input images we are going for processing. Major challenge is processing speed. We have the Core Studio system, old Lenovo system I have. Core Studio. I am given that input. I took 10 hours for getting the output, right? And I have hypernet mode. I will keep my laptop, and after that, after running the system, I will produce the output from after 10 hours. That processing speed is you have to be cautious with the medical images, right? And retrieval rate also. Other processing make time to increase the raw trained data is that processing time required for retrieving that input image is very long, because of course we got that feature vector database. That system has to match with any one of the already trained data. Minimal classification we are going to take. That minimum classification value we are going to take as an input. That we have to calculate the high noise levels, low contrast, poor resolution, etc. are also the major factors for causing the problems in medical image processing. This also we have to take into account for calculating of the problem of medical images. Now we come for histogram equalization. You know very well. Whatever the images I have given to the 0 to 255 value. Inside 255 value, the gray intensity value of 0 to 255 values of the input intensities can be given as a graph. And enhanced images also I have given, right? That values I have enhanced image histogram values. Say, but the quality of that histogram can be easily found, right? The input image. So having what we need to calculate is mean square error, signal to noise ratio. These two parameters also have to calculate for error rate. Having not calculated simply accuracy, error rate is also important. Error rate means what? How much error, how much reduced amount of errors we are diagnosing for that input image is also important. We have to reduce that error rate. We have to improve the accuracy. You should not confuse with that. Reducing the accuracy, improving that error rate is not required or suggested for any medical research. For that, we have to use the improving that input images by way of low pass filtering, high pass filter. I already know. Calculate having inserted the low pass filter, high boost filter. What is the value of MSC and SNR? Signal to noise ratio. We are calculating, right? Reduced amount, that mean square error. Signal to noise ratio is expected, right? Now we go for interfacing that engineering and medical science. The screening challenges of the things. Complex image interpretation, high volume of data, small viewing time. These are all the screening challenges. High volume of data, complex image interpretation is there. So why we go for both the combinations of radiologist as well as the CAD system. I already told CT scan radiologist even can observe the things and he can write the things. What is the use of the radiologist to find? What is the use? For example, in this slide, I am giving the detected. Radiologist on seeing can detect something, right? By using that CAD system, we are incorporating that CT scan images into your machine learning algorithm. Very few things are missed. From the oversight value, that oversight can be divided into some missed value. CAD in general, CAD can miss something. In general, radiologists can miss something. Both the combinations of radiologists as well as the CAD, that missing parameter is very, very less. Right? Having detected majority, 90% accuracy, we can achieve with both the radiologists as well as the CAD system. So improving the CAD helps visualization of enhancement for visual analysis, right? Visualization means what? Finding that enhancement, detecting the result, disease manifestation, and measurement of the various structures in terms of length, volume, etc. Say, for example, I am going to concentrate on the breast cancer images with the CAD mammography image. Right, this is simply a X-ray type of breast tissue, and two images I have given from left side and right side. The left side abnormal tissue showing the dense white on mammogram. The left scan images showing that abnormal breast, right one shows the malignant calcification. Once we have that white dense picture in your CT scan mammography image, the white parameter. Just to see the right image, is it visible to all? The right picture value and left picture value. Left picture value is having the white light of intensities and drastically it spread all over that scan images, and taking into account for right side, the white intensity value is somewhat higher than that of the left. So there is a possibility of malignant calcification in the right image. So I am giving the breast image or thoracic image as an input. The organ segmentation carry out, breast boundary, lungs, colon is calculated, and lesion type of abnormality segmentation, nodule polyps, that is lesion, that is segmentation part is second whale. Third, I am extracting the feature. I already told where the texture features or shape features are. Geometrical properties I am extracting from that input image. I go for classification. I am telling that it is malignant or benign. Benign means non-cancerous and malignant means cancerous, right? And finally, I am going for evaluating and interpreting the system, whether it is the person or the patient is affected with malignant, cancerous or non-cancerous. So microcalcification with respect to the breast cancers method, most of the deposit of calcium will be seen in the mammography. Tiny deposit of calcium in breast image can be seen in mammography. If majority of calcium deposits are harmless, suppose we are having a small percentage, maybe precancerous or cancer, we need to identify those kind of precancerous or cancerous, that the cells begin abnormally and may spread throughout that breast, right? So common type of breast cancer begins where actually it's milk production ducts. In that, the common type of breast cancer segmentation or cells will starts spreading, and cancer may occur in lobules as well, the breast tissues as well. So, for example, these images you see here, the white is seeing here, and the malignant, it is benign. Malignant type of images it is identified with our system. One more difficult case with respect to identification or detection or diagnosis of breast cancer is fibroglandular tissue. Fibroglandular tissue means what? White areas may hide the tumor. Of course, white areas may spread around the CT scan images or mammography image. Of course, the intensity of white here also the calcification, spreading of calcium is also may spread identified as a white tissue. Then we have to categorize. The younger woman is having the more number of glands, more number of ligaments. Then we can say the dense breast tissues. Possibility of identification is more. That identification of cancerous more for the difficult with that aging, right? With aging, breast tissues may become fattier and lesser number of glands is there. Cancer is relatively easy to detect when compared to younger one. Then aged people can easily identify because number of glands is reduced and it is relatively easy to detect. So this one, this image is something called as the characteristics of CT images, CAD characteristics, that breast cancer images or lung images having given here. So just take into account these images, all type of calculations can be here done. That the geometrical value of analysis, how much size, dimension, thickness, intensity, sex, everything can be given here in the diagram mammography. Having this image, we are giving this mammography image into our CAD system. Now we are calculating that reader one is calculating the first type of features is calculating globalization for malignancy 5, highly suspicious, sphericity 2. One type of image given with that values, right? And second reader value marked as 1, malignancy 5, high suspicious, sphericity 4. And third reader, of course, we have globalization value is 2 only, malignancy 5 and sphericity maybe 5. Like that only we have to calculate. And all type of parameter calculation is also given here with our CAD system as well as the radiologist value. Calcification, we are going to calculate 6 parameter, popcorn, laminated, solid, non-central, central, absent. The internal structures like fat, fluid, soft tissues, everything we have to take into account. And possible scores for everything will be validated For margin, poorly defined, sharply defined, sphericity, linear or round or oval, and speculation, marked or none, right? Textures value, non-solid or solid or mixed values. Like that values of tabulations we have to specify in your research values. The characterization of features also can be given: circularity, area, roughness, elongation, compactness, eccentricity, solidity. These parameters you can take. Having collected the feature values for that mammography image, you need to calculate all these parameters. And minimum intensity or maximum intensity, contrast value, all these features can be taken into account with respect to size. Finally, we go to conclude that whether it is malignant or benign. And selection of features with respect to SNR, signal to noise ratio, peak signal to noise ratio, means square error on entropy, equidistant distances can be used for classifications, perimeter or convex perimeter, major or minor axis, rectangularity, convexity, solidity, all these you can take in your work. For texture features, I already told mean, median, variance, skewness, autocorrelation, right? All these can be incorporated. Feature extraction is the process of generating features and classification of the task. You already know, right? We have to discriminate our values with the original values. The features can be classified and the shapes can be given for your texture features, right? For your shape geometrical analysis, right? Round, oval type, lobulated, nodular, stellate, right? And you can give accordingly your value in the form of the shapes as well. The circular shape can be given as circumscribed margins can be given. Well-defined margin can be given lobular shape. Ill-defined margin can be given the speculated shape like a stellar. The challenges we are finding in the characterization of that image is large number of training samples and features and dimensionality problems can be given. Training samples number will be very large. Variation in nodal shape and size, I already told. Various shapes like circular or oval or stellate, right? Different types of imaging acquisition parameters are there. Clinical evaluation also be collaborated with medical experts. We cannot straight away tell with that. We have to discuss with your medical experts or hospitals once you produce the result. Classification of tissues can also be classified in that angle: average intensity, average contrast, smoothness, second moment, uniformity, entropy. Right, these parameters we have to incorporate in your research, like compressed and fatty, non-uniform, high density. What is the pixel value? Calculated value will be there. A comparison will be here. Region growing, water, three type of segmentation methods they have taken for the same input image. One is called region growing methods. They are getting the entropy value as 1.5. Watershed algorithm, they are taking the entropy value as 1.43. K-means clustering, they are taking the entropy value as 1.57. And signal to noise ratio, they are taking the value 23.65, 31.74, 28.65. Whatever may be the segmentation methods you can take for your work. All these feature exam, finite machines, Gabber, AI, and artificial neural network, your methods are going to incorporate, and sensitivity, specificity, and accuracy value also going to be incorporated in your values. Like true positive, true false positive, true negative, and true value. All these values can be already given. What is true positive, false positive, true negative, false negative? We have to calculate the sensitivity value for all the features, specificity value for all the features, and finally we are calculating the accuracy level for the input image. Accuracy level I have given for various ranges starting from 94.2 to 93.81, and if the accuracy level is more than that of the already previous work, now your work is somewhat good when compared with other one, and we have to take into account other parameters also, like error rate, reducing of error rate, as well as the computational complexities as well, and calculating the performance of that CAD, true positive in fact and false fraction graph also we have to carry out. Now we coming to the machine learning. Already told that overall value is artificial intelligence. In part of that artificial intelligence, we have the machine learning. Inside the machine learning, we have supervised learning and unsupervised and semi-supervised as well. Deep learning is a part of machine learning, right? Subtitle of machine learning. Finally, it will be more More than that, of the conclusion part, that whether it is malignant or benign, that images also be given. Machine learning process given here. We are taking the trimmed image, we are having the grayscale conversion, we are extracting the features like energy, entropy, water level, autocorrelation. Finally, we are taking into account the feature selection as normal value and abnormal value, and we are concluding the training automatic classification algorithm we are giving. This is machine learning. Overall, all the features we are going to take. And what about the deep learning process? Deep learning process can be given with very few training the automatic classification algorithm with the test image. We are predicting that classifications with the trained images, and we are predicting the label case probability we are giving. But the deep discussions are there for machine learning than deep learning. And the common algorithm methods are given: supervised learning, unsupervised, reinforcement, semi-supervised, self-supervised, transfer learning, ensemble learning. These are all some of the learning style. And common algorithms are there, and applied area of medical device. Go through these slides. So many methods are there, like auto skew learning method, Markov decision process for reinforcement learning. If you go for semi-supervised learning, use the generative adversarial networks. Self-supervised learning pretext task is there, and transfer learning also inductive or transductive, so unsupervised as well. So thank you for the opportunities given. Any queries, please ask. Any queries there? How many of you are in the line? How many of you are listening to the today's slide? If
Sir, we
any,
are listening, sir.
uh, up to that I
Thank you, sir.
up to that I have prepared that slides 1.5 hours. I have some other work also. Now we can for 10 minutes we can go for a discussion, or we can wind up. Any
Okay,
faculty are
sir.
having doubt, because you are at that level of completion, you are having got the doctoral degree, working for your research for a paper preparation, or any funding research, you are going for proposal. Some of the faculties may be at that postgraduate level, having completed ME, doing PhD. It may be quite useful for you. And some of you are doing not registering PhD, but interested in research, doing the paper, presenting or publishing more number of papers. Three classification of peoples are there. And some, of course, you are doing any research with respect to medical imaging. This particular sites will be very much useful for you, right? That kind of things we are going to take into account. Any question or queries for you, ma? How many of the faculties are attending from a PSN set?
Sir, myself?
Ah, madam, you are attending?
Yes, sir, I am attending, sir.
How many others? Yamuna madam is attending or not?
Yes,
Yamuna madam is placement, busy with placement, other activities, isn't it?
yes,
Very
sir.
interesting. I thank CSC HOD Dr. Varghese sir. He is doing a lot of things for the benefits of students right from the beginning itself. 6 years I have traveled with him, worked with him. He is concentrating so many things. So many FDPs for faculty he will conduct. So many number of latest topic for the students as well. Workshop, seminars, organizing, right? Hands-on training for the students. You keep on doing all these things for the favor of students. This is very important, because simply by learning that subjects with your syllabus we are framing, we are learning. Apart from the subjects, what industry is required, what research is looking for, that gap we have to fill. The research gap we have to fill by get the idea through this kind of faculty development programs, right? We congratulate Dr. Varghese sir for giving this opportunity. Anyone is having that any question, please ask, or let us go for winding up the session.
Dear participants, if you have any queries, kindly ask with our resource person. I think so all are understand about this classification and everything, sir.
Okay, sir.
Thank you,
Okay,
sir.
madam.
Thank you so much for
Okay, madam.
coming
Thank
and
you.
delivering the needful information. Thank you so much, sir.
Thank you, madam. Thank you.
Thank you, sir.
Okay, sir.
Afternoon. Okay, madam. Thank you.
Okay, sir. Okay, dear participant, we are wind up the session. We will again we got to join at 2 o'clock. Thank you all.
So today we are going to discuss about a topic with respect to Industry 4.0 as well as Industry 5.0. This is a very emerging field with respect to technology growth as well as for research aspect. So, for many researchers, there are lot many opening is there for Industry 5.0 related issues as well as challenges. We will have some discussion with respect to how.
Excuse me, sir.
Yes, yes,
Sir,
sir.
please,
Yes, sir.
please share your screen, sir. PPT
Yeah,
screen.
yeah, just.
Okay.
Is it viewable, sir? Heading: Data Science Powering Industry 4.0 and Industry 5.0. Is it
No, sir.
viewable? No.
No,
No,
sir.
Okay, okay. Please. Is it clear?
Yes, now it's okay, sir.
Yeah, fine, sir. Fine, sir. So, welcome you all for this workshop. So, I thank the organizers who have invited me for this workshop, so I can get some opportunity to interact with our fellow academicians. So, myself, Dr. M. Gokul Dev from Department of CSE Data Science from Vailtech Rangarajan Institute of Science and Technology, Avadi. So, I welcome all you for all for this online workshop, and it's a great opportunity for me to interact with you. And so let me give you an idea about how the data science as well as the industry 5.0 is emerging in the coming in the recent days. this. Why we are more focusing on the industry versions. The reason is that is the one criteria which provides. Excuse me. Hello. We call me at 4 o'clock. Okay, so this is the criteria. This is an parameter which will used as a measurement as well as for a criteria to understand about the growth of any such nation with respect to technology, as well as an economic growth is also considered based on how the industry versions is currently in the role. So that is why from the starting of 18th century itself, we are working with the term of industry versions like this, industry 1.0, 2.0, 3.0, like that. We are start from since 200 years back itself. Doing while the evolution of industrial revolution started, from that onwards, we are using this term industry 4.0. I mean, industry versions followed by the different versions from 1 as well as 2 until 5. Recently, we are moving to 5. Currently, we are working with Industry 4.0, and we are in the transformation stage of Industry 5.0. So this is what happening in the technological era. And the thing is, we commonly know that we are more focused on sustainability nowadays. So that is what the focus of Industry 5.0 also recently been considered. They are giving more importance for the sustainability based growth. Sometimes you will feel like most commonly we will think like the nature is been getting affected when the technology is getting growth. That is obviously happening actually, but still we are in now the industry 4. I mean, moving from industry 4.0 to industry 5.0. Most of the focus is towards managing as well as to sustain the environment. That is highly given importance for this industry. When you are doing along with sustainability based research challenges, it will be of highly expected in the with respect to paper publication as well as pattern. In so many cases, sustainability based concepts are getting more highlighted, and they're mostly they are in high need nowadays. So the young researchers, if you are working for any this research based task, or if you are trying to move towards an your PhD and something, for our PDF or whatever it is, if you are focusing based on sustainable based some goals, we commonly call this SDG, Sustainable Development Goals. That is of very important key term in nowadays technology growth. So if you are taking any aspect, there are almost some 17 aspects are there in SDG. If you are taking any one aspect from the SDG growth, sustainable development goals, and you are trying to give some innovative solutions for the challenges which is coming across through this SDG, there are lot many as well as that is mostly expected even in industry oriented as well as even for academic oriented growth. This sustainable based projects as well as sustainability development goal based papers are having highly impact is there. So that is one of my kind request if you are trying to work with this industry 5.0. Okay, and this is the excuse me. Once again, please. Yes. Now this is again the evolution from industry 1.0 up to industry 5.0. You can easily understand how different the industry revolutions have happened from the beginning to the recent days. Industry 4. I mean, Industry 1.0, there is no usage of any such electrical components or electronic circuits. Because ECS is nothing but electronic circuits. And from Industry 1.0, there is no usage of any such electronic circuits. That is purely based on mechanization, as well as some like based on the steam power, water based generations. Everything is completely based on these components, which is completely isolated from electrical based components or electronic based components. It is purely mechanic based. So that's why there is lot many scope is there for, we itself, before some 20 years, there is lot many opportunities for mechanical engineers. That is actually, it's an evergreen stream. But in the recent days, there is only when it is been combined or aligned with some technology that has been computer based technology or electronic based technology, then only it is gaining and gaining its popularity. Even we can know, like if you are taking any such automobile industries nowadays, 50% of their like their growth is based on the how much technologies they are using. We can find out lot many options in the vehicles nowadays in automobile industry. There are a lot many sensors they are using. Yeah, they are using different such sensors to measure the speed, mileages. They are using some sensors for guiding the vehicle without any distractions. So this is what happening now. So there is a lot many transition has happened in any industry along with the growth of electronic circuits. But earlier it is not the case. Industry 1.0 is completely based on and mechanic based like mechanic based components, and and normally use some steam power is the one they commonly use for many of the cases. So this is what the case in industry 1.0. But when it's going to industry 2.0 along the 19th century, they started using some electric power for some production of some components. Even we know about the different electric power based some, that's a growth of the industry revolution. Actually, after some around some 100 years after the industry 1.0, the industry 2.0 has kick-started the actual growth of the technology with the invention of with the involvement of electric powers, and they started they're preparing for mass production. So that is the one that made a lot many changes in the purchasing also has been changed during the 100 years of gap. So that is that there is a huge demand for the things, maybe food products, or whether it may be of any like cloths, any industry, textile industry. So there is a transition during this 19th century has lot many changes with respect to mass production. Say they could able to supply many people's demands. The demands ranges from food products. The demand ranges from textiles. The demand ranges from some basic electrical requirements. So all those things happen during industry 2.0. So that is the kickstarting period of the growth of the industrial revolution. And same like in industry 3.0, that is again it's very we call it as that Y2K growth. That in the year of 20th century, from around the year of 2000 onwards, we can see the usage of computers in every places. So that is an again one of the major transition from industry 2.0 to industry 3.0. So now during the industry 3.0 itself, they have decided about how the usage of electronic circuits. That is one of the most very important thing that played a vital role in the growth of the industry. So the industry 3.0 has an involvement of electronics as a substitution for electricals. So previously in Industry 2.0, the industrial revolutions depended on electrical systems alone, but in Industry 3.0 onwards, the usage of electronic circuits made an important role in the development of the most of the technologies. So that is we know the many companies like electronic companies like Siemens. These are all one of the leading companies that has played a vital role in the transformation of this industrial growth, right? So this is what happened during the Industry 3.0 with lot many. That is again that automation of the work. See, even in the Industry 3.0 also the same criteria, like what people, most of the people said, like there will be a lose, most of the jobs will be lost. The computers has started its working. Now many of the people will not get job. So there was a talk was happened during the Industry 3.0's that period of 2000, when computers played a vital role in almost many of the this like some technologies, as well as in many of the systems. They started about yelling the growth of this Industry 3.0. They are not completely satisfied with the growth initially. The same thing is actually happening now also. We are also again we are thinking about how this industry is going to sustain if most of the work is getting automated. AI is taking its most of the jobs. It is happening, but still the thing is like there is parallelly whenever there is an technology is emerging, equivalent to that the skill is also has to be emerged. That is what happening in that is what not happening in many of the places. When the people could able to align with the growth of the technology, none of the job is going to be vacated, so none of the job is going to be replaced. But the thing is there is always, but still there is always a question about the ethical principle of AI. That is also happening. There is, but that still that is not an we can't say it is completely vulnerable. But still, there is more opportunities there for addressing the like with the challenges along with the growth of the of the current technology. So that is what happened during Industry 3.0 also. When we completely dependent on computers, but still we can able to understand many jobs are created after this usage of computers. Lot many infrastructure oriented changes has happened. The facilities also changed. Even India has seen a very important change, or it's for, the GDP also has a very important growth during the after the period of Industry 3.0. So that has happened because of the usage of the computers as well as lot many electronics devices for the industries. So the growth pattern has been changed during the period of 3.0. So it is always not to assume that there will be an downfall whenever technology is emerging. That is not a right assumption. So the thing is, what we have to what you have to think is how we can able to use this technology to manage the different requirements. See, for whenever there is some we have some available resources, even we can create lot many opportunities. So that is the place we have to focus more. See, in the period of like some 5 years back or 10 years back, there is no such expectations of there is no one would have imagined about the online delivery systems like Zomato, Swiggy. No one has imagined, like. But now that service is the companies those who are giving the sort of service with available technology, they are gaining in billions and millions and billions. So that is what the creation of opportunity. So when we have all these different facilities, we have to be more cautious about how to utilize the technology rather than worrying about how this technology is going to consume us. So that is a place we have to be more cautious. We have to accept. See, the growth is inevitable. That is what the case. The technology will not. The growth of the technologies is not going to be stopped. Okay, so it is keep on going. It is an exponentially. It is keep on growing. The thing is, we have to adapt to the technology, and we have to ethically we have to utilize the technology for the better growth of the growth of our person as well as for a nation. We have to find a strategy to align with the technology, and thereafter we can find an excellent growth in all the different aspects. Even for now the Israel. So one example is Israel. They have a lot many difficulties in some 100 years back. I mean some 50 years back. They had lot many difficulties with respect to usage of water. But nowadays, with the usage of technology, they are providing excess water now with the help of water management techniques, the help of technology based water utilization. Even for agriculture, they are using technology for adapting with agriculture. So now they are producing excess of water for for multiple purposes, more than what they need for the people. They are providing, they are generating excess water nowadays. So this is what is happening with different countries. So this is all about how we are utilizing the technology. Even countries like Dubai, we can see how much it's a deserted place, how it has been converted into a tourist area after some within a period of some 20 years. So that is what the usage of technology. So how come we are utilizing the technology will decide, or which will decide the growth of any such nation. So that is what the thing we have to take from this growth, right? And again, with respect to industry, currently we are in industry 4.0. This is all about cyber physical system. So nowadays we are using IoTs. Cyber physical is all about usage of machines as well as systems. So it is again a combination of human as well as a physical, human as well as a cyber system, followed by Internet of Things. So the usage of Internet of Things started with again in the period of Industry 4.0. Machine learning. So we very well know about the growth of machine learning as well as in deep learning. For many such different cases. Even see, that's what the thing is. So whenever we are using this technology, it is not only restricted for a single domain. Now the situation is like every domain should be we should be of interconnected way. There should be of interdisciplinary based research is gaining more popularity. Every domain should have an idea about other domains, and they should know to address the problems that every other domains are happening. So it may be of biotechnology. If your biotechnology people is having some challenges, that people from computer science, they should know how to address that problem with the help of some algorithms. So that is what we can call it as an interdisciplinary research. So that is gaining a very high requirement as well as that is of highly needed now. So how they find about the growth of some parasites. They can analyze the growth of some viruses, so that people from every domain should have the idea about other domains. So that is the need of the hour nowadays. Say if I'm a computer science engineer, I should know how the the aircraft is getting manufactured. What are the components needed? What are the different like technology I should use for the usage of such vehicles, and I should know about the autonomous vehicle. Even we know about Tesla. So the Tesla is again an automated self-driving. They're developing self-driving car, and the role of machine learning is very important there. So this is what we call it as the type of interdisciplinary. So the usage as well as the mechanical components will be working based on the the principles as well as logic of the mechanical engineer. So again, we need some machine learning engineer or some computer vision engineer to understand about the different objects and how it is moving and all those things. So this is what we call it as interdisciplinary. So whenever you are trying to address a research criteria, it is always very much helpful, or it is always very much in demand if you are doing some interdisciplinary research. So even it is very easy to get a paper published if you are doing some research in interdisciplinary based concepts. So again, this is what happened during the Industry 4.0, and now we are in the case of Industry 5.0. So this is what the this is the current situation happening. The transformation is happening with respect to Industry 5.0, where it is based on human centric. So Industry 5.0 is somewhat human centric. Okay, so now the thing is like the Industry 5.0 has been in the developing stage with respect to how the human can be given such a good environment. That's what I told initially. Sustainability based concepts are integrated into this Industry 5.0. So so there are a lot many. There are almost some 17 goals are there. We call it the sustainability development goals. You can check it later. So to address this all this goals with respect to technology, as well as to manage the resources with like to empower a better technology, but at the same time we have to reduce the unwanted wastages also. So that is what happening with respect to industry 5.0. And also that human robot collaboration is also one of the very important thing that is happening. So like when it is comes to an human robot collaboration, nowadays many people, even yesterday there is one story that happened in like in Japan, I think so. What happened is one robot, okay, one robot entered into a robot showroom, another one robot showroom, and it had some communication with the I think it's in China, okay, in Shanghai, I think so. So it has some conversation with another one robot, and it has kidnapped 12 other robots. It has happened yesterday, okay, yesterday or day before yesterday. This scenario happens. You can check it in YouTube or something. It is somewhat, it's very funny to get to know about this sort of situations is happening. So that one robot that is Airboy, okay, that's a robot name is Airboy. That is almost it's like a toy. It's a small toy-like object actually. It interacted with another robot which is about some 4 feet height. Okay, and they have started some conversation like it has been it's programmed to had some conversation with the another large robot, and it has been trying to make some some compromising languages it is using to ask about when we will go to home, like that it is asking. And that another large robot is saying, I don't I have I have no leave, I have to work for the whole day, like that it is replying. And again this small robot is asking, then you don't have any home? And again that large robot is saying, I don't have any home. Then this small robot is saying, then don't worry, you please come with me, I will take to my home, like that it is saying. And what happens, now all the 12 robots of that showroom started following the small robot, and it has been this is very viral in the actual social media. You can check it later, right, in YouTube and all, it is available. So this is what happening nowadays, right? So this is what the question mark actually. So how ethically we have to plan such technology? So how ethically we have to decide the usage of technology? So that is very much important here. Okay. So now the industry 5.0 is considering the human robot collaboration, and it should be of ethical, as well as it should be more, like it should be of concern with respect to how the human is, the human as well as environment, both put together, how much it is going to impact these human as well as environment in a positive way. That is what the industry 5.0 is much concerned. So here it is completely AI enabled. We are using lot many electronic circuits for this, combining the powers and humans. These are all the different modifications that has been happened with respect to industry 5.0. So this is the place where we have to think of the growth in a very positive way, as well as very ethical way. We have to focus the growth of industry 5.0. Any doubts until this about the industry emerging of industries versions? Any queries up to until this? Any question until this? Any queries? with respect to industry 5.0, it is a very emerging domain. If any researchers in the field, you can ask your queries, so I can able to give you some suggestion also. Okay, or else we can go to the next slide. Okay, so if not, we can go to the next one. Okay. Okay. So next one is, the rise of industry 4.0, digitalization, automation, and smart manufacturing. And now this is now we call it as the three pillar, like the three domains of industry 4.0, which integrates digitalization, automation, as well as the smart manufacturing. So in all these different aspects, the usage of technology is inevitable. Okay, and there is a huge demand for all the different some with respect to the demand of AI based engineers, the demand of electronic engineers, the demand for mechanic based engineers. All these different requirements has been merged or has been converged into this industry 4.0. So that is what with respect to the rise of industry 4.0, we can able to understand. There is a huge growth in the digitalization. The automation industry faced an excellent growth during this period, and the smart manufacturing is getting more popularity nowadays with the rise of this 4.0. That is very obviously we know this, right? And digitalization, integrating the digitalization digital technology across the manufacturing process, from design and production to supply chain. So in all the aspects, say even if I want to create one from the end-to-end service, okay, starting from a design of an car vehicle or design of any such component, from the design onwards, where there is a usage of digitalization technology from the design, then for testing, for then having a demo, and for end-to-end release from top to bottom. All such different components is completely utilizing this digitalization, and that is what the growth of 4.0 has been. That is more popular because that usage of digitalization is very common in all the industries. And automation. So the automation is again is one of the very emerging domain during this industry 4.0, and automation of task and process with intelligent machines as well as robots, boosting the efficiency and productivity. So that is also one of the key parameter for the growth of 4.0. That whenever we are doing some automation tasks, it was given a lot many opportunity for the productivity. So again, when it comes to the growth of any such nation with respect to the GDP growth, or with respect to the economic standard of a country, the usage of automation is again very important nowadays. And how much you can able to produce some some output, or how that is the throughput of any process, that played a very vital role during this automation period. So that is what happened during this period of 4.0 also, as well as smart manufacturing. That is also very important. The correctness of the manufacturing is more essential during this period. How much efficiently we are manufacturing a component, how efficiently we are manufacturing some component, what is the accuracy of each and every component. That is very important actually. So even if you are designing an automobile, it is now very important what is the inclination of the mirror of the mirror of the vehicle. That is also very important. That is also should be considered for measuring the mileage of the vehicle. What is the weightage of each and every like that the parts of the car. That is also very important. Even a small difference in the the design can also make a big impact in the they can create a lot many problem in the real time. So if there is an if there is an imbalance between the even in the tires of a vehicle, it will create lot many problem. Even inches difference will also create some like some trouble when you are not properly addressing that. That is what that smart manufacturing has gained more popularity. So even a minute errors should also be reduced, at least so that they can able to provide a better output for the as an outcome here. So that is why the Japan is very popular in the production. So that is how the Japan has reached an excellent growth in the with respect to the with respect to the developing nation. In many places what typically happened is Japan is by normally they will give more importance to accuracy. So that is how the principle itself, before even utilizing or using the technology also, the people in Japan, they have given more importance for the accuracy of production. So that gained them a very good name in the international standard level, and they have got lot many clients from different nations to procure their items what they are doing. Maybe the components needed for electronics are made with the components needed for mechanic are made the components needed for automobile. The industries in Japan has had an excellent growth when they have given more accuracy. By without technology also they have tried to give that knowledge with this growth also they are trying to give this accuracy. And nowadays after the usage of technology also they are giving lot many standards as well as they are raised their standards in international level. Now India also gaining lot many popularity with respect to production. Then automobile industry is also gained an excellent exponential growth during this industry 4.0 to 5.0. During this transition period they have utilized lot many technologies. Yeah, the usage of cars, in a single minute some 4 to 5 cars will be assembled in a single minute. That is what the the usage of technology they are using. So that is how the automation as well as smart manufacturing are embedded. In a minute of second, in a minute of time, how much cars can be manufactured? I mean, manufactured in the sense how much car can be assembled. So there are some different criteria like this. So what is the need is whenever there is an increase in the increase in the demand, there should be an increase in production, and whenever there should be an increase in production, there will be a growth in the usage of the things, and it will have a lot many other domains also will get the growth along with the manufacturing industries. So that is what happened during this industry 4.0. And the role of data science, so that is very important in the 4.0 series, and how much data you are collecting, how much you are that prediction is very important. With this current data, how I can able to find out, you can see lot many examples. Even Swiggy and Zomato they are doing research in lot many purchasing pattern of the users. So they are having many data science engineers in the company to understand the purchasing behavior of each and every people, as well
Excuse
as
me, sir.
yes,
Sir, a screen is not visible, sir.
not visible. I'm sorry. Is it visible now?
No, sir.
Still not visible?
Yes, sir. It will not visible.
Now it is visible? Is it visible now, sir?
Sir, not visible, sir.
Okay, I will stop it and again I will
Okay, sir.
just. Is it fine, sir?
Sir,
Is it now? Now is it clear, sir?
so now visible, not visible the screen, sir.
Now is it clear, sir?
Hello, sir.
இப்போ clear இருக்கா சார்?
இல்லை சார், இப்போ ஸ்க்ரீனே வரலையே அது Zoom மீட்டிங்ல. இட்ஸ் நாட் விசிபிள் சார். ஸ்க்ரீன் நாட் விசிபிள்.
நான் ஷேர் கொடுத்துட்டேனே. சார் நான் once again ஜாயின் பண்றேன் சார்.
ஓகே சார்.
இப்போ ஓகே சார்? சார் இப்போ ஓகேயா?
சார்
இப்போ ஓகே சார்?
நாட் விசிபிள் ஸ்கிரீன் சார்.
அப்படியே கிளியரா தான் வந்துட்டு இருக்குது சார். சார் எனி சேஞ்சஸ் இப்போ தெரியுதா? டிஃபரன்ஸ் எதுவும்?
சார்
ஒரு நிமிஷம் சார்.
சார் ஸ்கிரீன் இட் நாட் விசிபிள் சார்.
மறுபடியும் ட்ரை பண்ணலாம் சார். எனக்கு கிளியரா இது ஷேரிங்ல உங்களுக்கு எனேபிளா இருக்குது சார் ஆக்சுவலா.
சார் ஓகே சார். நவ இட்ஸ் க்ளீன் சார். ஓகே சார். ஓகே சார்.
ஓகே சார். ஸ்லைடு மூவ் ஆகுதா சார் இப்போ? ரெண்டு ஸ்லைடு மாத்திட்டு இருக்கேன். அதே மாதிரி அங்க எனேபிள் ஆகுதா?
மூவ் ஆகுது சார். மூவ் ஆகுது சார். ஓகே சார். ஓகே சார். Okay.
So again, so the role of data science in enabling industry 4.0. So that is many, in most of the cases, we know how the role of data, now the case is like one who can able to work with data, now they can able to earn in million and billion. So that is what the data usage of data is that much important. So, like starting, we again coming to the example of Zomato or Swiggy, they don't run any hotels, correct? So, to connect the data with respect to hotels as well as the customers. They can able to connect the people as well as they could able to connect the restaurants with the help of data. So this is what the thing happening nowadays. So one who are having a lot many idea about data, now the days are for those people who can able to do wonders with the help of data. So that is why the data science is gaining more popularity. So it is not the earlier days, we can run anything with whatever information it is having. Now the thing is like we have to foresee the, like the things for some 20 years. Okay, that is how any business can grow nowadays. We have to think how it will be after 20 years, how it will be after 30 years. So based on this vision only, we can able to start any such new aspect. So that is why the data analysis is very important. So if you want to predict something, so how it will be after 20 years, how the schools will run after 20 years, how the colleges will run after 20 years, how a typical hotels will run after 20 years, and what are the different changes may come after 20 years with respect to automobile, and what are the different changes may come with respect to gaming industry. Likewise, some we have to have a vision for some 20 or 30 years before launch of any new technology. So that is why the data collection is also very important. We have to understand, we have to predict what will happen if that is the case. So what will happen if from short range to long range, short range to from long range, we can able to make this sort of predictions. Even Redbus, they use a lot of data analysis for different time. So for weekend, we can see that rate of tickets will be more. During weekdays, it will be high. If the number of tickets booked is less than some 20% of the actual seat, automatically the prices will be reduced. Likewise, it won't expect any manual interventions. So whatever it is being fed with the data with respect to some algorithms, now it can able to automatically make use of all those things. This is what the usage of data is very important during this industry 4.0. So we need to know how we can able to analyze the data, and we have to know how we can able to predict something out of data. Even from a shop of a tea shop, also they use the method of data analysis. They know if it is very highly it is raining, they will find out some different they will try to increase the number of snacks they are producing. So that is also an example of data analysis. They will predict. So if it is extremely if it is rainy, they will reduce the number of that coffee and teas. So this is also an example of prediction modeling. So why I am saying this is from a normal a day-to-day shop to even for a large technology-based company. All the different aspects of the business will need the usage of data analysis as well as the predictive modeling. So that is what we call it as the growth of industry. We are trying to reduce the unwanted wastages, and the industry 4.0 is also concerned with involving the optimization parameters. So optimization in the sense what is available, with that available resources, what we can do. That is an example of optimization. And how much we can able to efficiently manage the available resources. That is also an example of optimization. How we can able to accept, or how we can able to make every people to utilize the technology with respect to with respect to the available resources. And there comes the role of optimization. So these are all enabling parameters with respect to data science in the industry 4.0. And predictive maintenance also very important. Even with respect to ISR or NASA, they're all completely they are working towards the real-time monitoring scenarios for each and every single seconds. That they are trying to get the input from the different satellites. And from different base. From the stations, international space stations, and all these things are example of real-time monitoring. And again, if it is running some any high-level industrial applications. It may be of some nuclear power plant industry. Okay, Kodamkulam nuclear power plant. They are very much in need of the real-time monitoring. Okay, even a small mismatch can lead to a big disaster actually. So this is very important for monitoring the cases. We know about the case of Bhopal case. How a small incident has made a huge disaster. That is because there is an accident. That is because of we don't have that time. There is no technology to actually measure the abnormal activities. So there is no proper mechanism to observe or to track the abnormal cases. So that is why that's during that sort of time, Bhopal faced some very abnormal disaster. So that is why nowadays for a very sensitive industries, the real-time monitoring is very important, as well as it is very essential for predicting. Also, it is very it is very inevitable. Even a small second, if there is any mismatch, it leads to a greater disaster. So the real-time monitoring is extremely important, and even we know about the story of Star X, where Sunita Williams and other astronaut is being struck with in the Starliner. So because of some mismatches in the sensing data, okay, based on some sensitive data. So this is what we are very much moving towards this sort of real-time monitoring. And here also the data is very important. Even a small a microsecond data is also more important to us. So this is possible only when we are using some high efficient electronic circuits along with some sensors, which will help us to get a better prediction when it comes to the real-time monitoring. Okay, so this is also very important with respect to the industry 5.0 and the supply chain optimization. So this is also one of the place where there is an usage of industry 4.4 is very inevitable, from starting from the demand forecasting, inventory management, transportation optimization. In all this different, this one you call it as an example of supply chain, from starting from the place of there's nothing but an example of logistics. Okay, this is an example of supply chain, starting from the production of any such items until the delivery of the items to the concerned people. All these different aspects we can call it as a supply chain, starting from demand forecasting, inventory management, as well as transportation optimization. These are all very important for enhancing any such industry within supply chain based optimization. It can't be done in an with some on-demand cases. We should have some pre-planned workout. We should have some different plan A, as well as we may have some plan B. So through this only we can able to take any such decision at the right time. So that is why many of the companies will always have a proper supply chain management itself is a separate domain actually. So that is one of the most important domain with respect to industry as well as manufacturing sectors. Okay, so this pyramid will give you an idea of how that every such domains are interrelated with each other, and all these interrelated items we can call it as an example of supply chain management as well as supply chain optimization. See, there is not many research aspect is there in the supply chain also. So you can, if there is any research aspect based you are working, supply chain optimization is also one of the very emerging field with respect to this research aspect. So you can also have some idea, as well as you can also refer something based on this supply chain, and again some algorithms also you can implement to give some new phase of supply chain based optimization. This is also gaining more popularity. And industrial IoT and sensor data. Now this is, we can, as we told already, the real-time monitoring, connected systems. So these are all very important. So from starting from every day nowadays, all the devices are connected. Okay, so there is less number of setback is now been reduced considerably. With the help of this sensors and other cases, we can easily connect with different aspects. We can easily connect with different devices. The help of sensors, as well as with respect to any such environmental based cases, and for hospitality, for respect to hospitals or medical healthcare sectors, and with respect to manufacturing, all the different domains, they are using a lot many different sensor for their growth of the industry. So this is very obviously this is also a part of the industry 4.0 that has an that played a very vital role in this industry 4.0 generation. So here also there is a lot many openings for as well as challenges for the research based aspect. And generative design, this is again an example of the transition from the 4.0 to 5 industry 5.0. So design algorithms, the help of many generative algorithms, we can able to find different types of we can give some solution with respect of different design aspect, as well as the human evaluation. Like how many engineers we can generate some different types of designs with respect to feasibility. That's what I told earlier. There is even a small changes in the design of any particular component that may have a very worst impact in the other side if it is not properly designed. So these are all the things we have to address during this transition of industry 4.0 as well as 5.0. We have to, that correctness is very important. So that is what the growth says. So whenever it is being, we are utilizing everything in a proper and efficient way, automatically the wastages will be reduced, as well as the sustainability goals also will be it won't be compromised. We have to follow the sustainability development goals, as well as we have to improve the accuracy. In this way, we have to move the transition from the industry 4.0 to industry 5.0. And in workplace also, there is a lot many opening for this, with the help of this work, we can call it as workforce optimization. So here also we can make use of the data to understand different types of workforce. Nowadays, there are many tools are there for the help of AI, with respect to recruitment also. Earlier there is, even now the many colleges also, they are doing recruitments, campus recruitments, with the help of robotic based interviews. With the help of virtually the interviews are being done. Virtual in the sense they are not in online or something. That interviews will be completely through some automated machines, with the help of an UI user interface device, where the questions will be asked by with the help of automated generated questions will be there. That machine itself will interact with us rather than the human based like interviews. Nowadays, even the colleges in Tamil Nadu also, they have done some interviews based on virtual based in that AI. Based on AI itself, the interviews are happening. So there is no need of humans. The machine itself will ask the question. The machine itself will it will ask some generate the it will participate in the conversations dynamically. It will ask the question. In between also, it will try to it will understand the answers of the users, and it is responding according to the answers. Likewise, there is opening based in case of the talent acquisition also. Now there is based on this data driven and the AI. Now many such emerging fields are coming in this field. So this is also one of the things that happened during this industry 5.0, industry 4.0. And again, this is industry 5.0. That's what we told already. It should be towards human centric. It's very sustainable, and it is very resilient manufacturing. So this image itself can able to give you an idea about what is happening in industry 5.0. We have to align with the with the robotic based with the technology, or with the robotic based technology. We have to work along with this technology, emerging technologies, and it should be a collaborative case. It should not have any impact on the and the sustainability of the planet, as well as it should try and the human should have the it should have the eligible, they should have the like mindset to work along with the technology, as well as they should be more resilient. Whenever we are creating that with the technology, we should be of more aligned with the human, and it should be more more or less it should be of it should be based on how the environment can able to sustain all the different changes. So this is it's all based on how we are ethically utilizing the technology. That is again the thing we have to reset again. It may have some impact if it is not properly utilized, or if it is not properly considering the AI ethical usage of this AI. It is all up to the standard as well as level of usage based on the human, as well as the with respect to the technology. So this is very important. So that's what here we can see that second point, integrating environmental consideration into every stage of the manufacturing process. This is what we call it as sustainability. So how we can able to manage the available resources, how we can even manage the water resources, how we can even manage the pollution. I mean, how we can able to manage the air pollution, how we can able to manage the noise pollution, how we can even there is light pollution is also very. It's nowadays it is creating lot many problems. We will love, but we may normally worry about the air pollution, but similar to this, light pollution is also is getting. It is also having lot many problems. You can please check about the drawbacks of light pollution nowadays. It is completely that is also one of the reason the global warming is global. I mean the effect of global warming has also the impact because of this light pollution. So these are all the things we have to consider when we are moving to the next level of industrial evolution. Okay. And and this is an example of a tree we can able to with it, but this is with respect to an European digital sovereignty, so it is based on a proper standard they have designed for how the different trees we can able to create, and what is the structure of the tree that we can able to create all those things. That is what they call it as this particular tree structure. So here we call it as the actual root as well as the base of the tree is all about the fundamental technologies for Industry 5.0. We can use for AI tools, methods and algorithms, and SOS. SOS is nothing but system of system, that we call it as system of system based architectures, and microservices for AI supported. And we can go for some we have to be answerable for the trust, acceptance, ethics. That is what we can able to understand here. So that's what from the beginning I am saying. So this Industry 5.0 is very concerned about how the technology is going to help the customers, how the technology is going to help the people in various aspects. So that is how this Industry 4.0 has been transitioned to Industry 5.0. This is very important. They are giving more concern for the human-based, human-centric sustainability productions, and that is what one of the thing we have to be more happy with this Industry 5.0. And the challenges that are awaiting to enable the Industry 5.0 involves challenge one, which is all about Industry 5.0 needs to promote skilled jobs as well as mass customization with humans guiding robots for enhanced customer satisfaction. So this is industry, that is one of the challenges. We need to promote more skilled jobs. So we from Industry 5.0, there is a growth of semiconductor industry is gaining more popularity. So those people who are all in the searching for some technology to learn the semiconductor based industry, some programming like Verilog programming, these are gaining more popularity nowadays. And those who are gaining a good understanding in this VLSI as well as Verilog programming have lot many opportunities in the next decade. So that is very important indeed. That is one of the challenges we have to take from this Industry 5.0. As well as challenge 2, unlike previous transformation, Industry 5.0 must focus on greener solutions. That is very important, greener solutions, and protect the natural environment through the adoption of bioeconomy, leading to a sustainable environment. This is one of the emerging term. We call it as bioeconomy. In the sense, the economy should grow with respect to the consideration of the biology, even with respect to the ecosystem of the people, or the help of the with the overall biological aspect of the environment. Based on this, the economy should grow. So in the previous industry revolutions, there is no consideration much is given for the natural resources. There is no that much importance given for the biological environments. But in Industry 5.0, we are giving lot many importance for this greener solutions, natural environment, as well as bioeconomy. This is a very emerging term, and there is lot of research opportunities there with the help of respect to bioeconomy. And the challenge 3 is again there is need of predictive analytics as well as operating intelligence. This is also very important with respect to if you could able to create a very good model, very good model for some algorithmic based model, or if you are trying to create some models for operating based, so the help with say if you're creating some new models, with respect to saying like if we are in machine learning and deep learning, there are many such models are there, and we can also provide some many optimization based algorithms also gaining more popularity. Hybrid based, some algorithms also is getting many popularities. Heuristic algorithms are getting many popularity. Likewise, we can create some many different, analytics as well as algorithms which will help this industry 5.0 to gain more popularity. That is also, it is one of the important aspect. And challenge 4 is again automation will play a more significant role in the production process with real-time data obtained from machines and highly skilled specialists collaborating. And this is also, that's one of the challenges. There should be always an special, high skilled specialist is important to align with the role of this industry for 5.0. So that is very another one challenge we have to consider. So that's what we told already. Whenever the technology is growing, the specialists in that field to develop the skilled professionals are always in demand. So never ever please blame the technologies, but the thing what we can do is let us grow along with the technology, and we can reach some better, we can find out some better solution with the help of the technology. There is more chances for lot many entrepreneurships with the help of this new emerging industry 5.0. There are see lot many businesses are trying to they are moving to another paradigm of businesses through this challenge, with the help of this new growth of technology. So we should always be optimistic to find out what are the challenges we can able to address and how we can able to grow along with this technology for the better growth of the people as well as the better growth of the nation. So that is how we have to focus on the challenges what we are facing. Okay, and again, this is challenge 6, and it is we know it is a human-centered adaptation requires continuous innovation. So this is very important. There is a even though we are having we are moving through different transitions from industry 1 to industry 5. Still, there will be always opening will be there for challenges as well as for innovations. So the innovation aspect is very important. We can think for all possible innovations. The facilities are enormous nowadays. The computer-based facilities, the machine-based facility, the cyber-based facilities, everything are enormous. The thing is, if you could able to give some innovative thought, if you could able to provide some innovative solutions, then it is always a better choice to we can proceed to the next level of the growth for the betterment of the for the country as well as for the whole world. We have to keep on focusing on the innovation, whereas the facilities are already available. If you could able to substitute our innovations along with the available facilities, then again it can able to convert into a large, it can convert into a model, as well as the model itself it can be converted into a system. That system can provide a lot many job opportunities, that can provide a lot many productivity. We can increase the different productivity of the particular input. So these are all things that can happen when we are going through different challenges. And this is an example of, we call it as talent acceptance model. Okay, this is an example of so any model, if you are trying to innovate or if you are trying to provide some different innovative solutions, it should address all these different levels of this acceptance models. TAM stands for your technology acceptance model. This one is an architecture, will give you an idea of how the technology has to be considered based on various aspects. One is, we call it as perceived usefulness. How much useful that product will be, that is we call it as perceived usefulness. And next one is we call it as PEU. It is all about perceived easy of use. It is all about how easy it is to use the particular innovative product. So that is also one of the things that has to be addressed, and followed by the perceived trust. So that is what very important nowadays. And again, the trust is very important in the nowadays. The trust is nothing but we can also call it as a security. So if whenever we are using some technology, we have to ensure that the technology is much reliable, as well as the data is much reliable, and we can able to trust the particular model in different aspect. So that is also very important in the coming days. See, that is in whatever the case it is, once after the usage of industry 3.0 itself, the security is playing a very vital role. The security of the devices, the security of the users, the security of the things, with respect to Internet of Things, the security of the things whichever involved, everything is gaining popularity nowadays. So if we are doing some research with respect to the industrial, with the industrial transformations, it is again there is challenges is there with respect to security aspect. How, and even nowadays quantum computing is gaining more popularity. That quantum based, like key management techniques are available. Quantum based security algorithms are now gaining more popularity. So as if you are trying to again move to some new version of the technology, again quantum computing is one of the gaining method, as well as gaining domain, which has lot many opportunities in India as well as abroad. So there is, if you are gaining any certifications, or if you are very much skilled in the field of quantum computing, you can get a wonderful opportunities, even in India as well as abroad. There is a huge demand for engineers who have knowledge in quantum computing, as well as quantum computing based security aspect. So there's chances you can able to you can able to refer there. And as well as social influences, and whenever you are trying to innovate a product, how much social influence it is going to create, how much impact it is going to create to the society, that is also, it is very important nowadays. Many times we can say there is always a clash between nowadays the Uber as well as local auto drivers. So this one has to be addressed actually. So how come, what is the useful, how much people are gaining advantages with the technology, how many people are gaining they are facing trouble with the technology. These sort of considerations also has to be addressed when we are trying to provide this sort of models. So that is what we call it as social influences. So how much, whenever we are providing some technology, how much impact it can able to provide to the society, that is also very important. As well as FCs, we call it as facilitating conditions. And another one aspect we can call it as facilitating conditions is all about what are the things we can need for this innovation, and how much facilities we need, whether it can be easily given to a people from a place, from the developing nation to developed country, whether it can be easily been intruded towards the lifestyle of the people. That these sort of things we have to be measured before providing any such new innovative categories. And again, this role of semiconductor is very important in this industry 5.0. So that's what again I'm saying, those people with trying to find out again some new trying to learn some technology, there is a huge scope for semiconductor for the next 10 to 20 years. And even many companies, semiconductor companies, are they you can see the stock value was also getting raised because of the high demand. The thing is, like, the usage of AI, machine learning are actually, they are directly proportional to the growth of the semiconductor industry. Say for example, if we need to train some model, okay, if we have to train a model for a lot many, with many input data, if we have to train a model in a very excellent way, we need a lot many machines. So whenever we need a high-end machines with more processors, we need more semiconductor based processors. When we need more semiconductor based processors, we need many semiconductor based chips. So that is very important for the processor to be affixed. So likewise, whenever there is a growth in the AI industry, the growth is also will be parallelly, it is now gaining in the semiconductor industry. And nowadays, even you can see the latest, the thing is, Nvidia, that is one of the semiconductor based company, is becoming number one. They have taken over iPhone, okay, they have taken over Apple, and to reach the number one spot with respect to the most profitable company in the world. Now when compared to the Apple, now Nvidia server providing company is number one in the most profitable industry, most profitable company in the world, which is an example of a semiconductor growth. So that is very important. So you can able to find out some opportunity in semiconductor industries to gain the popularity of industry 5.0. And there are many methods we can that is available, starting from neural network simulation, digitalization, augmented reality, size one, big data, algorithms, digital twin, energy harvesting is gaining more popularity. Virtual reality is having lot many opportunities nowadays. Machine learning, cloud and fog computing, deep learning, AI, sensors, virtualization, predictive maintenance. Say these are a lot many technologies. We need some IoT, from IoT to implement Industry 5.0. So these are the technology which we use along with IoT to implement the Industry 5.0. Similarly, there are some methods to implement 5.0 using industrial Internet of Things. This is also gaining more popularity with respect to the growth of industry IoT, with respect to with respect to industry 5.0, with the help of industrial Internet of Things, predictive maintenance, energy consumption. Nowadays, even the smart meters are gaining more popularity. Similarly, AI-based production and logistics is gaining more popularity nowadays. Holistic value chains, that is one of the actual research domain. It is gaining a lot many popularity in the days that are now coming days. They are gaining more popularity in the recent days. And actuators, that is, it is one of these major case. From all the different industries, they need this usage of actuators. The design of actuators itself is one of the different most required field nowadays. Indoor food production, robotics. So robotics is gaining excellent growth in all the different management sectors, starting from the from automobile industry, and even for food manufacturing industry, and for any different like industrial for many industrial purposes, may it be in hardware, or it even for many automobile based industry, is gaining more popularity. Machine learning models is seeing continuous growth in the recent days. There is no substitute for this industrial machine learning models. The continuous evolution of machine learning is gaining more popular nowadays. And as well as the human centered AI, that is very important in the recent days. It should be based on the human, the growth of human, as well the need of the human, as well as the AI should be hand in hand with each other. So that is also one of the most emerging field with respect to industrial IoT. So these are all the things we have to consider while we are moving from the industrial 4.0 to industry 5.0, as well as semantic data models. This is also having one of the excellent opportunity with respect to research as well as the industrial purposes. So this is what happening with respect to the industrial transitions. So what we can conclude is the Industry 5.0 aims to strengthen the industry through embedding the AI tools and methods into the whole manufacturing chain in an end-to-end manner. The integration not only leads to a more efficient utilization of energy and resources, but has the potential to bring resilience, competitiveness, and sustainability to a whole new level. That is what from the beginning itself we are saying. Industry 5.0 is going to make a huge transition, but all the transition is going to be with respect to human centric as well as the sustainability. So these two things has to be addressed in a very efficient way, and that is what the expectation of Industry 5.0. And Industry 5.0 signifies a significant advancement in technological innovation and the societal impact. So that is also very important. How much it is going to impact the society, that is what the technologies always, we will prefer the technologies, so that whatever the technology that is emerging, that should be of more unique, or that should be of more impactful to the society. So that is one of the evergreen demand for any such growth, and it advocated for the adoption, expansion, and implementation of AI-enabled hardware, tools, methods, and semiconductor technologies in the journey towards Industry 5.0. So that is what I am saying from the beginning. Nowadays, AI as well as semiconductors also gaining more popularity. So if you are trying to do some new learning, so the learning the semiconductor based tools, learning some semiconductor based programming languages like VLSI, as well as for Verilog programming, or any such tools like Cadence tools for designing. Likewise, they are gaining more popularity. So definitely next 10 years, there will be a huge demand for the engineers and researchers and academicians who are in the field of semiconductors and having some idea in in some programming languages like Verilog and VLSI based designing. So this is the opportunities we can generate out of this industrial 4.0 to industry 5.0. So this is what I like to share with you. So any such queries, you can please go ahead. We can have some conversation, and any doubts also we can clarify.
Dear participant, if any have any doubt, kindly ask with our resource person. Okay. All silence to be considered as all are okay. Thank you. Anyway, thank you, sir. Thank you for your valuable guidance and then presentation, for giving how the future is available for our industries 5.0 and what are the innovative technologies can be available for in forthcoming years. And thank you so much for your valuable information.
Thank you,
Thank
madam.
you, participants. The feedback link to be provided via your WhatsApp. Thank you so much.
Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.